In this video, we are looking at the zero of a function. Before we define it, let's say, for example, if we have that the function f of x equal to 2x minus 2, and we're asked to find the zero of this function. What we simply need to do is to equate it to 0 and say that f of x is equal to 2x minus 2 equals 0. What this means is that 2x is equal to 2. So x becomes 2 over 2, which is x is 1. So what it means is that the value that x will have and this function will become equal to 0 is 1. If we check, we'll have that 2 times 1 minus 2 will give us 0. So 2 times 1 is 2, 2 minus 2 is 0. So if we define the zeros of a function as the input value that produces an output of 0, sometimes we call it root of an equation. Now let's look at another sample before we get to the complex functions. If we want to find the zero of the function f of x equal to x squared minus 8x minus 9, the next thing we need to do for here is to equate this to 0. So we'll have x squared minus 8x minus 9 equals 0. Since we equate it to 0, we can now factorize. If we factorize, what are the two numbers that when we add them together they give us negative 8? When we multiply them together they give us 9. Those numbers are plus 1 and minus 9. So we can say x plus 1 and x minus 9 equals 0. Therefore, x plus 1 is 0. What this thing means is that x is equal to negative 1. Or x minus 9 equals 0. Therefore, x equal to positive 9. So let's check. If we check, the equation remains 8 squared minus 8x minus 9. So if we say for x equals negative 1, put it here, we have negative 1 all squared minus 8 times negative 1 minus 9. What we're going to have is this is 1, this is plus 8 minus 9. So this is 9 minus 9, which is 0. So that value is valid. So the next check we can look at is when x is 9. For x equal to 9, what we can do is we rewrite the equation x squared minus 8x minus 9 equals 0. So 9 squared minus 8 times 9 minus 9. We want to check whether it will be equal to 0. That's what we are checking. So here is 81 minus here is 72 minus 9. So we want to check whether it's equal to 0. Here 81, here is also 81. So it is actually equal to 0. Let's look at another question. To find the zero of the function f of x squared minus 6x plus 5. Feel free to pause the video and try this. For us to solve it, we will equate this function to 0. We set it to 0, which is x squared minus 6x plus 5 equals 0. We can factorize it. What are the two numbers? When we add them together, we get negative 6. When we multiply them, we get positive 5. Those numbers are minus 5 and minus 1. So we can have x negative 5 and x negative 1 equals 0. What this thing means is that x minus 5 equals 0. Therefore, x is 5. Or x minus 1 equals 0. Therefore, x is 1. So the values are 5 and 1. So we can still check for when x is 5. So if we check for when x is 5, we have the equation of the function to be x squared minus 6x plus 5 Let's check. Impute 5 into here. We have 5 squared minus 6 times 5 plus 5. Want to check whether it is 0. Now, 5 squared is 20. And here is 30 plus 5. Let's see whether it will be equal to 0. Here and here is 30. 30 minus 30 is 0. So, they're correct. Feel free on your own to also check for x equal to 1. It will still give you 0. So the next question we can look at, let's increase the tempo a little. Given the function that x squared minus x minus 12 over x squared minus 9. Let's find the 0 of this. Now, whenever you have a rational function, all you need to do is to set the numerator to 0. If we set the numerator to 0, what we're going to have is that x squared minus x minus 12 equals 0. So since we have this as equals 0, we're going to factorize two numbers that when we add them together, we get negative 1. Now when we multiply them together, we get negative 12. They are negative 4 and plus 3. So what we're going to do is x minus 4 and x plus 3, which is equal to 0. So the first one, x minus 4 equals 0. Therefore, x is 4. The second one, x plus 3 equals 0. Therefore, x is minus 3. So these are the two numbers. We can still check. If we check for x equals 4, the function is x squared minus x, just the numerator alone. We want to check whether it is equal to 0. So what we'll do is 4 squared minus 4 minus 12. This is 16. This is 16 minus 4 minus 12. Here is already 16. So 16 minus 16 gives you 0. So it works. It's correct. You need to know that this same value must not give us 0 as for the denominator. For x equal to 4, let's check it with the denominator. Denominator is x squared minus 9. Let's check to make sure that it is not equal to 0, because if it is equal to 0, then it will be undefined. So this is the denominator. We'll say 4 squared minus 9. If we do 4 squared minus 9, we're going to get 16 minus 9, which will give us 7. So it means it is correct, because if the denominator is 0, then it will be undefined. Let's check for x equal to negative 3. For the numerator, x squared minus x minus 12, we'll have minus 3 squared minus 3 minus 12. Let's check whether it is 0. This is 9 minus 3 minus 12 minus 15. You can see that this is not 0. So since negative 6 is not 0, let's check the denominator. The denominator is x squared minus 9. So we impute minus 3. Minus 3 squared minus 9. You have 9 minus 9, which is 0. So for when x is minus 3, you have an undefined value for it. So this minus 3 is not actually a 0 function. Rather, we call it a point of discontinuity. That's a hole in the graph. So the only 0 function for this particular function that we are dealing with is actually x equal to 4. This is the only 0 function for it. So let's also find the 0 function for this function f of x equal to x squared minus 4x plus 3 over x squared plus 3x plus 2. Feel free to pause the video and solve this one. What we have to do is we set the numerator to 0, and the numerator is x squared minus 4x plus 3 equals 0. So the next thing is to factorize it. the two numbers, they multiply to give 3, they add up to give negative 4, and those two numbers are negative 1 and negative 3. So we'll say negative x minus 1 and x minus 3 equals 0. So we can say that x minus 1 equals 0, therefore x is 1, or x minus 3 equals 0, therefore x is 3. So we have two numbers also here, minus 1 and 3. So let's check for x equals 1. If we check for x equals 1, from the function x squared minus 4x plus 3, we want to check whether it is 0 when we impute 1 in the place of x. So we have 1 squared minus 4 times 1 plus 3. Let's see whether it will give us 0 now. This is 1 squared, this is negative 4 plus 3. So this and this is 4. 4 minus 4 is 0. So is a 0 function. Let's also check for the second value when x is 3. When x is 3, we will have 3 squared minus 4 times 3 plus 3. So that what we're going to have to see whether it is 0 is here is 9, here is 12, and 3. This and this gives us 12. 12 minus 12 is 0. So the zeros are actually 1 and 3.